This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on income streams. Let's start with a discussion of probability density functions. These are very important in statistics. The first requirement is that the function is non-negative for all x, so no negative values for the function. The second requirement is that the total area under the graph is exactly 1. 100% probability. The total area under the graph is 1. And our third condition is that if we want to find the probability that some number is between c and d, that is simply the integral from c to d of that function f of x dx. If these three conditions hold, then we have a probability density function. So we're told that the life expectancy of an appliance is a continuous random variable that has this as a probability density function. But let's convince ourselves that it really is a probability density function. So the function is defined as 2 over x plus 2 squared for x greater than or equal to 0. So you assume the function is 0 for all of the values where x is negative. So we can look at a graph of that function. So indeed, 2 is always positive, x plus 2 squared is always positive, so the function is always greater than or equal to 0. That takes care of our first condition. Our second condition is that the integral under the function must add up to 1. So the integral from 0 to infinity, that's where this is defined, must be 1 for this to be a probability density function. And checking on Wolfram alpha, indeed, that is the case. So this satisfies those first two conditions, and then we'll go ahead and define the third one, being the integral from c to d will be the probability that the life expectancy is between c and d years. So here's the question we want to ask. Find the probability that the life expectancy for an appliance is between 0 and 4 years. That will require us to integrate this function from 0 to 4. And the value of that integral will be the probability that we'll get between 0 and 4 years from this appliance. So let's quickly do that integral. This is going to require a u substitution. U will be x plus 2. The derivative of u with respect to x is 1, so du is dx. X plus 2 will become u. Dx will become du, but let's change the endpoints. This is x is 0. U is x plus 2, so that'll be 0 plus 2. Here x is 4, u would be 4 plus 2, or 6. So emphasizing that point again, x plus 2 is u, dx is du, u is 0 plus 2, u is 4 plus 2. So now we have the integral as u ranges from 2 to 6 of 2u to the negative 2. Let's remind ourselves of the power rule. The integral of x to the n is x to the n plus 1 over n plus 1. So we'll get u to the negative 2 plus 1 over negative 2 plus 1, or u to the negative 1 over negative 1. We have to evaluate that as u ranges from 2 to 6. Now 2 divided by negative 1, our constants here will just be negative 2. So we have negative 2 u to the negative 1 as u ranges from 2 to 6. But what does u to the negative 1 really mean? Of course it means 1 over u. So we have negative 2 times 1 over u as u ranges from 2 to 6. And I'm just going to pull the negative 2 out to make my life a little easier. So this will be negative 2 1/6 minus 1/2. Which gives us negative 2 times negative 1/3. So the probability that an appliance will last between 0 and 4 years total is about 2/3. So at the end of 4 years, 2/3 of those appliances will no longer be functioning. Okay, so let's move from probability density functions to continuous income streams. So you'll notice the same sort of process occurs, and then we're going to integrate from a to b to find the area under the curve. But this is not representing a probability this time. This is representing total income for an income stream. So if you have something like a vending machine, you will be continuously getting money into that vending machine. So we have to describe the rate of flow. And the total income is simply the integral from the starting time to the ending time. F of t is our rate of flow, total income, integral from a to b of f of t dt. Let's look at an example. So our rate of flow is 400 e to the 0.05 t. We are interested in the total income in the first 2 years. And again, this is a very small business. Not much money is being collected here. So we're going to integrate from 0 to 2 of that income stream function, 400e to the 0.05t dt, finding the area under the curve for that function. We're going to do a u substitution. So u is 0.05t. du dt is 0.05. Of course, the derivative of 0.05t is 0.05. So du is 0.05 dt. Du divided by 0.05 equals dt. So e to the 0.05t will become e to the u. dt will become du over 0.05, but I still have to change the endpoints. T is 0, so u is 0.05 times 0. That will still be 0. Here t is 2. U is 0.05 times 2, which will become 0.10, 0.1. So again, there's our substitution, e to the u, du over 0.05, and we've plugged in t into this formula. U is 0.05t. Plugged in the t of 0, plugged in the t of 2. So we get 400 divided by 0.05. U ranges from 0 to 0.1 of e to the u du. 400 divided by 0.05 is 8,000. So I have 8,000 e to the u as u ranges from 0 to 0.1. That'll give us 8,000 e to the 0.1 minus e to the 0. E to the 0 is, of course, 1. Factoring out the 8,000 to make it a little bit easier. And then getting a decimal approximation, we have a total income over 2 years of only $841.37. Not going to be able to retire with that sort of an income stream. Okay, now we want to look at the future value of a continuous income stream. So f of t is the rate of flow of a continuous income stream. T starts at 0 and ends at t. If the income is continuously invested, so as money comes in, we continuously invest it at some interest rate r. We want to see what is the future value after t years. So you're told what the income stream is. You're going to invest all that income, and you want to find out what is the total value, what is the future value of that income stream. So here is the formula for that. Integral from 0 to t, starting at 0, ending at t. F of t is our income stream. Then we have e to the r. R is our rate, our interest rate we're getting for investing. Big T is our ending point, minus little t, that's what we are integrating over. And simplifying that, of course, e to the rt is perceived as a constant here because little t is what's changing. So the formula we're going to use is e to the little r big T, integral from 0 to big T, of f of t e to the minus r little t dt. This will give us our future value of a continuous income stream. And again, what does this represent? The future value of a continuous income stream is the total value of all money produced by the continuous income stream, income and interest, at the end of t years. So let's look at our same example. Again, you can't retire on this, but we're going to invest all of our income at 7% compounded continuously over 2 years. So we know what our little r is. Little r is 7% or 0.07. We know what big T is. We're doing this for 2 years, so big T is 2. We know what f of t is. F of t is our continuous income stream, 400e to the 0.05t. So making all the substitutions, you will see that e to the r, 0.07 t2, integral from 0 to big T, integral from 0 to 2, f of t, 400e to the 0.05t, e to the minus rt, e to the minus 0.07 rt dt. So setting this up is really the greatest challenge. Now it's a matter of going ahead and evaluating the integral. So 0.07 times 2 is 0.14. That'll give us e to the 0.14. And over here you'll notice we have the same base, so we can add the exponents. E to the 0.05t, e to the negative 0.07t. Adding them together, we're going to get e to the negative 0.02t. 400 is a constant. That could come out. Of course, this is going to require us to do another u substitution. So u is negative 0.02t. The derivative of u with respect to t is negative 0.02. du is negative 0.02 dt. du divided by negative 0.02 is dt. So we will get e to the u. dt will be du divided by negative 0.02, but then we have to change our endpoints. T is 0, u is negative 0.02 times 0 will also be 0. T is 2, u will be negative 0.02 times 2. So from 0 to negative 0.04, but 400 divided by negative 0.02 is a constant that can come out in front of the integral sign. So you'll notice what we have, 400 divided by negative 0.02 times e to the 0.14, integral as u ranges from 0 to negative 0.04 of e to the u du. Now, the derivative of e to the x is e to the x. Integral of e to the x is e to the x. Integral of e to the u will be e to the u. So you'll take e to the u evaluated from 0 to negative 0.04. First off, though, I just divided the 400 divided by negative 0.02 to make my life a little easier. And here we go. Antiderivative of e to the u is e to the u, integrated from 0 to negative 0.04. So negative 20,000 e to the 0.14 times e to the negative 0.04 minus e to the 0, which of course is just 1. And after all that work is done, we get a future value of $902.06. Not that much more than the answer we got before. And to remind you, that answer was $841.37. So the difference of the answer we just obtained and this one would be the total interest earned over that time frame. And let's look at one more problem. We want to find the future value at a rate of 3% compounded continuously for 5 years of a continuous income stream with a rate of flow f of t equals k, a constant. Some constant rate of flow. So finding the area under the curve of a constant would be easy. We just want to see how we can use that for this model. Our t will be 5 years, our r will be 0.03, and our f of t will be k. So reminding ourselves of the formula, the future value is e to the rt, so it'll be e to the 0.03 times 5. Integral from 0 to t, integral from 0 to 5 of f of t constant, e to the minus rt, e to the minus r minus 0.03t. And this is what we have to integrate, but that's not terribly difficult. 0.03 times 5 is 0.15, so we have e to the 0.15. K is a constant. K can come out with that e to the 0.15. And now we just have to integrate from 0 to 5 of e to the negative 0.03t dt. And of course, that's another one that needs a u substitution. So by the same process we've done earlier, u is negative 0.03t, du dt is negative 0.03, du is negative 0.03 dt, du divided by negative 0.03 equals dt. So e to the u, dt will be du over negative 0.03, and we've got to change the endpoints. Negative 0.03 times 0, and negative 0.03 times 5. The negative 0.03 here can come out as a constant, so we'll have k e to the 0.15 divided by negative 0.03, and we're integrating from 0 to negative 0.15. The antiderivative of e to the u is e to the u. We'll evaluate that from 0 to negative 0.15 to go ahead and get our answer. So we'll have k e to the 0.15 over negative 0.03 times e to the negative 0.15 minus e to the 0. E to the 0, of course, is 1. And then putting that into the calculator, this part, the e to the 0.15, the negative 0.03, and the e to the negative 0.15 times negative 1. Multiply all that by k, and we get 5.394k. Now remember, the integral of a constant from 0 to 5 would have just been 5 times that constant. We get a little bit more. The 0.394 extra is due to the interest we're getting over that 5-year period. And that will conclude this lesson.